And the last point in this chapter, where we prepare tools for investigation of a function, the last point is how to find asymptote. Asymptote is a straight line with the property that the graph of the function goes closer and closer to this line if we go far away from the origin. And there are three types of asymptotes. A vertical asymptote, which looks like that. If we have a graph and it may happen that there is a vertical line, then the graph goes closer and closer to this line if we go further up or further down. This is when the limit is infinity. And the limit of the function for x approaching a either from the right or from the left or both is equal to either plus or minus infinity. An example of such a function is 1 over x, because limit for x approaching 0 from the right is infinity. And the graph is hyperbola, and the y-axis is the vertical asymptote for this graph. Another example is tangent, which is sine of x divided by sine of x. Tangent looks like that. For minus pi half and pi half, it has again a vertical asymptote, and similarly for the x values, because the function is periodic with period pi. A typical situation of a function to have a vertical asymptote is when the function is in the form of a fraction and when the denominator goes through 0 while the numerator remains away from 0. Here, when x goes through 0, the fraction goes to infinity and then minus infinity, and we have a vertical asymptote. Similarly here, cosine goes through 0 at every odd multiple of pi half. Sine at these points remains away of 0, so the fraction goes to plus or minus infinity, and the graph has again the vertical asymptote at every point of that. So that was the vertical asymptote, and how to find it. If the limit for x approaching a from the left is plus or minus infinity, we have again a vertical asymptote. Horizontal asymptote looks like that. It may happen that the graph of the function approaches a fixed value when we go far away to the right or to the left. This can be written that limit of the function for x approaching infinity is some finite value. So if we have a finite, that means proper limit at infinity, at some improper point. Or we can have limit for x approaching minus infinity, and then it looks like that the graph approaches this horizontal line. An example is again 1 over x, because here the x-axis is again an asymptote at infinity and minus infinity, or the function e to x, which goes to 0 when x goes to minus infinity. So this graph has a horizontal asymptote on the left, that is at minus infinity. And the general asymptote is an asymptote in the form some constant times x plus another constant, where k and q are two real numbers. Actually, the horizontal asymptote is a special case of this one if k is 0. And these two exclude each other. If we have a horizontal asymptote there is no general asymptote, and if we have the general, then we don't expect a horizontal asymptote, because the function cannot approach two different lines when we go to plus or minus infinity. And now we want to find some algorithm how to find k and q, and how to find whether the graph has such an asymptote.